Good morning to everyone. We're going to start today's session. So first, I would like to recap yesterday's session. In the yesterday's session, we were looking at how to create calculation views of type star join. So what is a calculation view? First of all, calculation views, you can use data sources like information views and tables. You can use operators, join, union, projection, aggregation, rank. There are three different data categories inside a calculation view. One is known as dimension, the second one cube with star join, third one cube model. What is a dimension? A dimension is the perspective in which you would like to analyze data, nothing but for master data. So we created two dimensions. One is the customer dimension and the second one is the material dimension. Customer and material dimensions, the customer and company code dimension. Customer and company code dimensions, we also created in attribute views. We also created in calculation views. The dimensions which we created in attribute views, we use in NLT view. The dimensions which we created in calculation view, we use in cube with star join. The limitation of cube with star join, we cannot use attribute views. So to replace attribute views, we use calculation views of type dimension. So in the day before yesterday's session, I'll log into the remote desktop connection. So let's give the username and password. So yesterday we replaced the CPU. Now everything is working fine. So let's go to HANA Studio. Click OK. Let us log into the system. Let's log into the system. Let us expand content, expand the package ECC March 7:30 AM, expand the calculation views, double click on CV company code. We created calculation views of type dimension. We created CV customer, calculation views of type dimension. Double click on, so today we are going to create calculation views of type star join. So I'll just delete this. I'll delete what we created yesterday. I'll recreate again. I'll delete and activate. So before I even create a star join, I would like to create one more dimension that is for material. So here we have two dimensions. One is the company code, the other one is the customer. So I would like to create one more. So calculation view, click new, provide the name at underscore, sorry, cv underscore material. Subtype is standard, type is graphical, data category dimension. Just I would like to finish this dimension called material. So once I finish, now I'll have three dimensions: company code, customer, material. So whenever you create a calculation view of type dimension, the default node is projection. Click finish. So once we finish, so in the work area, in the scenario pane, we see semantics, projection. Whenever we select dimension, the default node is projection. So click on join, click on join, click on the work area, click on the plus icon, enter Mara for material master. From best schema, click OK. Again, join one, click on the plus icon, MAKT. From best schema, click OK. Now, from join one, best Mara and MAKT. So in here, we need to add joins between both these tables. So I'll add MATNR to MATNR. Join type is text join. Language SPRES. MATNR, material group, MATKL, MATKL. And MAKTX. So once we are done on this, a link join one to projection. Click on the projection. MATNR, MA. Sorry, I think selected wrong column. MATKL. I need to select this MATKL, which is metal group. Excuse me. So click on the projection. So here you have MATNR, MAKTX, and MATKL. Click on the semantics, key attribute, MAKTX, validate, activate. So now we have three dimensions. CV material, right click, click data preview, and click raw data. So here we see materials and material descriptions and material group that each material belong to. Now, I right click on the calculation view folder, click new again, CV underscore actual underscore plan underscore COPA underscore data. I'm providing the technical name, description, label, data category, cube, click on this checkbox with start join. If you set the data category as a cube, the default node is an aggregation. If you change the default node to start join, you can change the default node to start join by selecting this checkbox. Click finish. Once I click finish, the default node in here is a start join. In the dimension, the default node is a projection. So now, what is my requirement over here? My requirement here is I need to combine both actual plan data for COPA. So I'll take both of these tables. First, I'm going to click on the projection. Click on the projection. Click on the projection on the work area. The projection 1, I'll right click on the projection 1, rename this as actual. Click OK. Click on the projection again. Click on the work area again. Right click on the projection 1 again, rename plan. Click OK. So first I'm going to combine both these tables in union. So on the actual projection, I'm going to click on the plus icon. Enter the table name CE1 IDA from best schema and click OK. In the plan, click on the plus icon, add objects. Enter the table name CE2 IDA. From best schema, click OK. So here we have both actual as well as plan projection. So here we have actual and plan projection. So what we are going to do is now I'm going to select required columns from this projection called actual. So click find for KNDNR, ARTNR, find for company code, and VV010, VV070. I selected these columns from actual projection. So these are the columns that are available in output. So all these are available in my output. How I've done in actual, I'll click plan. I'll click on the plan projection. Click find. Find for similar columns KNDNR, ARTNR, BUKRS, VV01, 0001, VV07, 0001. Excuse me. So now here we find all these 5 columns similar to actual and plan. So both having the similar set of columns to the output. So now I have 2 tables, one is actual and the other one is plan. Now I'll click on the union. I want to combine both actual and plan, so I'll click on the union. Click on the union on the work area. So link actual to union and link plan to union. Click on the union node. Click on the union node. Right click, rename. You can rename the union. Actual plan union. Click OK. Click on the union. So expand plan. Expand the actual. So this is details pane. In the details pane, you see source and here you see target. The source we have plan, actual. I'll select these columns. Right click, add to target. If you have the same technical names, we can use auto map by name. Just we can click on this auto map. Once you click on auto map, once we click on this auto map by name icon, the columns that have the same technical names will automatically map. It's difficult when you have a lot of columns. To do it manually, it is very time consuming. It is time consuming. So what we will do is you can just click on this auto map. Once you click on this, automatically it will map except for the columns which don't have the same technical name. Please see here. VV010001 is plan and VV010 is actual. Because they do not have the same technical name, if you see K and DNR, both have the same technical name. So it will add to the target. So I'll right click and delete these columns. Remove target columns because I want to combine measures. I'll right click on VV010, map to target. So this is the source column. So what is the target column? This is the target column, gross revenue. So I'll select VV010001. Excuse me. Click create. I can link VV070 to VV07001. So VV010 I link to VV01001. VV070 I link to VV07001. Now, what is happening over here? Let us try to understand. So when we do a union, what we are doing here is, please see, let us take company code, BUKRS. So BUKRS is 1000. Excuse me. We have a measure called VV010001. This is plan. And we also have a measure VV010. This is actual. So company code 1000, plan. So what's my plan? I'll take it as 2000 USD. So what's my actual? Let's say 1000 USD. Now when you want to calculate variance, so plan minus actual, you get the variance or the difference. But what is happening over here? BUKRS, we're trying to combine company code. Also, we're trying to combine VV010001. VV01, VV01001. I'm trying to combine into a single column. Because the aggregation type is sum, the aggregation type is sum for a measure. So what's going to happen now? The output will be something like this. BUKRS 1000. So what's the output here? VV01001. Obviously 2000 plus 1000 it becomes 3000 USD. But I do not want to happen like this. I want to combine at the same time, I want to differentiate. I want to combine as well as I want to differentiate what rows are coming from I want to combine, I want to differentiate. Just give me a second. I'm just taking for more easier to understand. 1000. Plan is 1000 USD. Actually, it's 2000 USD. So you have both this BUKRS. This is plan and this is actual. So what is happening now? This is the output. This is the This is output when you combine. So BUKRS 1000 becomes 3000 USD. But this is not what I'm expecting. My expectation is I want to differentiate from both these rows. But this is coming from where? This row is coming from CE to IDA. This row is coming from CE1 IDA. So in order to differentiate both these rows, I'm going to create another column called indicator. I'll create a new column called indicator. Once I create this new column, I will tell to this column that whatever the rows that you get from CE to IDA, give a constant value. Give a runtime constant value. Say, you're getting from CE to populate a runtime value called plan. If you're getting from CE1, populate a runtime value called actual. And then it cannot combine like this. So this will be my output of union with constant values. So this is nothing but this is called as union with constant values. So when you do a union and then you assign a constant value by creating a new indicator, you assign a constant value data coming from CE to plan, C1 is actual. So I'm going to create a new column called indicator and I'm going to assign runtime values for each of these rows that are coming from different projections. So here, usually you cannot see this plus icon. What we have to do is we have to little expand this to, you have to expand until you see this plus icon. Continue to expand. Continue to expand until you see this plus icon. Usually this is hidden. You see, this is hidden, you don't see this. So continue to expand until you see this plus icon. Click on the plus icon, create target. Create columns that you want to use in the union view, which are not mapped with the source columns. So I can create a new column called indicator. Which is varchar actual and plan would like to take it as 10. Creating a new column, click OK. This is a new column. Right click on the new column, click manage mapping. So for this column, we are trying to map. So what we are trying to map, manage mappings for indicator. Map the target to either a source column or a constant value. I do not have any column in the source which tells the indicator, okay, this is actual and this is plan. I do not have any source column. So what I'm going to do, I have a source model, actual, so I'll give a constant value, actual to this column. If you're getting data from plan, indicate the value as plan. This is the data type and this is the length, and click OK. And now link the union with start join. Link union with start join. Click on the start join. Click on the start join. So once you click on the start join, these are the columns of my fact table. I have 3 foreign keys, 2 measures, and 1 attribute. One is local attribute. So in here, can we drag and drop 80 company code inside start join? PC? I cannot. It doesn't allow me to drop. So that is the reason, instead of using an attribute view, I created same CV company code. I'll select drag and drop. Can we drop? Yes. So what does this mean? A dimension of an attribute doesn't allow inside a star join. A dimension of a calculation view can be allowed inside a star join. So that's the limitation. So I'll even drag and drop customer. I'll even drag and drop material. So once I drag and drop these three dimensions, I'll expand this output column. I'll expand the calculation views. Here you can see all these three calculation views of type dimension in the output. So here we see columns. Inside the columns of a star join, I haven't selected. I'm trying to adjust this. So I'll click on auto map, auto layout. I'll click on auto layout. It'll try to arrange itself. So what columns are required here? VV010, VV010001, VV070001. I need this indicator. So here I selected columns are required for output. Now once this is done, I'll join key attributes with the foreign keys. I'll join key attributes with the foreign keys. So I'll get this attribute views near to the fact table. I'll get this attribute views near to the fact table so that I can comfortably join. And then I'll link BUKRS to BUKRS, KUNNR to KNDNR, MATNR to ARTNR. Now this is similar to an analytic view, but the only difference we find between an analytic view and a star join is analytic view is based on a star schema. A star join is based on snowflake schema. So can we achieve something like this in an analytic view? Where you're using actual plan, two fact tables, you're trying to use both measures from different fact tables. We cannot. And then what we also cannot do in an analytic view, first thing is we cannot use two fact tables in an analytic view, and also you do not have these operators like union, projection, ranking, joins. All these operators are not available. I can do this in the calculation view. So I can request data from two or more fact tables. I can use whatever operators I require. In an analytic view, you can only use attribute views and tables. In a calculation view, I can use all the views and tables. So once I join this calculation views of type dimension to the fact table. Now please see, when I click on the free space, you see there's a properties window. At the properties window, if you scroll to the bottom, so by default, what is the engine here? By default, the column engine is the calculation engine. What engine I want to execute this? I want to execute in the SQL engine. But for now, I'm just keeping this as blank. I do not want to change to SQL engine. I'll just keep this as blank. But this is the engine that we want to execute later. So I'll validate, click Save and Activate. The view is activated. CV actual plan COPA data. I'll right click on the view, click Data Preview, click Data Preview. What I'm going to do now, just to show you, I'll drag and drop this indicator, which I created in the union, to the labels axis. So in the runtime, you can see I populated for C1 actual and for plan. I'll drag and drop this VV010001. Now, can we actually see what is my actual and what is my plan? So how many milliseconds it has taken? 172 milliseconds. I also would like to analyze for actual and plan based on each country. I'll select Landex, drag and drop Landex to labels axis. Now it takes around 297 milliseconds to execute the view. Now again in Landex, I'll select Landex and drag and drop to the filters. I only would like to analyze data for, say, Germany. So for Germany, the actual value is this. This is the gross revenue for Germany, and this is the gross revenue for Plan Germany. Like this is for United States. United States actual gross revenue, and this is the Plan gross revenue. So what I'm trying to show here is, now the time it takes to generate these reports. You're seeing when you drag and drop an indicator, it has taken 178 plus, and then for land 1 it has taken 250 plus milliseconds, 265 milliseconds for Landex. The volume of data that we have in these views is very less. When you compare in the real world, you have millions and billions of records. But the volume of data that we are actually now doing is probably something around 75,000 records. For actual and for plan, it is another 60,000 records. So totally, if you see, it is 1 lakh plus records. Means not even 1/10 of a million. So the volume of data is very less, but still we managed to get this to 265 milliseconds. Now, when we execute this star join, when you execute this star join on a default engine, that is nothing but the C engine. So default engine is a C engine. It takes around 265 milliseconds to execute this view. So we discussed one point on the other day. Star joins are not optimized to be executed on a C engine. When you have mountains and mountains of data that you want to process, especially on an operational system, when you have ECC powered by HANA, CRM powered by HANA, any of the business suite of applications, when you want to create, SAP introduced a special engine called SQL engine, which is known as an SQL engine. So using this engine, using an SQL engine, you can execute the star join to be executed on SQL engine. But the real power of SQL engine you will only know when you have mountains and mountains of data. But still, we'll see when you execute on an SQL engine how fast when you compare with a C engine. Let us see this. But what is the criteria? We have to change each of the views that you're using For a star join, we have to explicitly go and change to an SQL engine. So let us do this. So I'll go back to HANA Studio. I'll go to each of these views. First, I'll go to company code and let's verify. I'll click on the free space. I'll click on any of the join. I'll click on the free space. I'll scroll to the bottom. I'll just scroll to the bottom and execute in SQL engine, validate, activate. Similar, let's go to customer, click on the free space, click on any of the node, then click on the free space. Then let's scroll down, execute in SQL engine. This is already modified. So let's go to CV material, click on the node, click on the free space. So I'm going to change to all these views to SQL engine, execute in SQL engine, validate, activate, and then let's go to CV underscore actual underscore plan underscore COPA underscore data. So now in here, I double click on the view, click on the free space on this view as well. Click on this free space, scroll to the bottom, execute in SQL engine, and let us finally save and validate and save and activate. So now we know whatever we are using in the start join, now we change to execute in SQL engine. We just change this option. So now let us go back. I'll right click on the calculation view, click data preview. So again, I'll drag and drop VV01 0001 to values access, and then I'll drag and drop Landex to labels access. So usually if you see, the time it takes to execute on this engine is 172 milliseconds approximately. So the view is same, nothing changes we have made. When you execute on SE for the same amount of data, it takes 265 milliseconds. When you execute on SQL engine, it takes around 172 milliseconds. The query is same, data is same, view is same, everything is same. But the engine that processes this view is different. In the first case it is CE, the second case it is SQL engine. Now why is SQL engine faster? The reason is SQL engine has the capability to process better join determination technique. It can efficiently process the join conditions or any of the conditions that are there inside the calculation views of type star join. And C engine can process effectively complex calculations. This engine can balance between the joins and the calculations, and this engine is purely used for calculations. For example, currency conversions, unit of measure conversions. Complex calculations can be exploited using C engine. And this engine is optimized for graphical representation of models. And this engine is optimized for scripted based models. Complex calculations can be handled very effectively on the C engine. So this option is from SP8, calculation views of type star joins. Now, how do we know whether we have to go for an analytic view, whether we have to go for a calculation view? When a requirement is given, how can we identify? So normally business gives requirement. So based on the requirement, how do I choose whether I have to go for, because the output is same. In any of these data models you take, the output is same. But what is the difference is the engines that process this data is different. So I have to start from, if I want to start data modeling, first I need to know which engine is suitable for what data model. Simple. If you have master data, you want to create master data models, obviously you have two. Either you have to go for an attribute view or you have to go for a calculation view. If you want to use attribute views are optimized to process in an analytic view. When do we go to create an analytic view? When you have a single fact table. Analytic views have two important properties. One is faster aggregations and parallel processing of a query. These are star schema based on star schema. Especially if you see you have ECC system. Let's say this is an ECC OLTP system. Online transaction processing system. Data is continuously inserted into the systems, into different tables. There are different tables. Now we have another system called BW. BW is an OLAP system. So there is a connection between OLTP and OLAP systems. There is a connection between OLTP system and OLAP system. This is nothing but the communication. It happens using an RFC connection. So these tables on the source system, are actually denormalized. You have a business rules in ABAP. Different tables based on different conditions. They finally form a single table. And this table, which is nothing but, we cannot call it as a table, it's a structure. A table has content as well as the container. These tables together, they create a structure. This structure will have columns from different tables, and the logic to process these columns are finally written into this structure. So what I'm trying to say is, there is a place actually we are trying to denormalize. These are normalized tables we are trying to denormalize, which is suitable for data warehousing solutions. Now, what is the difference between a transaction table and a fact table? I always use this transaction table, fact table. A transaction table is a table. It's a term that is used in the OLTP systems. A transaction table is a table that contains data related to amount or quantity. Amount or quantity related data is nothing but transaction table. Master data tables. Master data tables are the tables which contain data about text, contain data about attributes on the source system side. Now these different tables which store transaction data. For example, You have a table called VBAK, which stores data related to sales order header. You have a table called VBAP. The data belongs to headers, data belongs to item. So when I create an order, for example 001, the total value of the order is 2000 USD. This 2000 USD in order 001, item 10, 1000 USD, 001 order 20 item, again 1000 USD. This is the net value of the sales document. So if you see, this is the way it stores data in this table. It stores detail level of data. And this is the way it stores data in these tables. So what I can do now, I can basically join both of these tables together. Based on a condition, I can join these tables together and create another table here. So instead of two tables, I'm trying to populate into a single table based on different join conditions. So this is nothing but I'm trying to denormalize table. A fact table is a table which is very huge. It contains data redundantly. Today we have facts, tomorrow again it adds data to the same table. So you have data redundant data in a fact table, which are very, very large when you compare with transaction tables on the source system. Here they override data, but in here they keep adding data to the table. So this is nothing but called as fact table. When you have large amounts of data in the fact table, the most important property is it has to scan this table very effectively. Scanning of these tables and aggregating the measures inside these tables in a very effective way. So when you're trying to get measures from two different tables, we're trying to denormalize and get this to another system, creating a fact table. Now you have measures from two different tables in one single table. So what kind of model I have to go? Analytic views. Why? Because we're already trying to denormalize data in here. Or we are trying to denormalize data in the BW system. I'll try to give more details about this now. We are only talking about order related data. Now, once the orders are created, you also require delivery related information, whether these orders are delivered or not. And also you require billing related information, whether the invoices are done for these orders or not. So you have data stored for orders in a different table, data stored for deliveries in a different table, data stored for invoiced in a different table. But finally, all these tables I require into a single table, which is nothing but, which gives me a complete sales overview, which gives complete sales overview. So how do I get my sales overview? Only when I have data from all these tables, orders, deliveries, and invoices into a single table, I can get my sales overview. Because we are already trying to, the only one thing I'm trying to highlight over here is we're actually having a place where we can denormalize. Now this is in a sidecar scenario. You have one systems which are optimized for doing inserts. You have another system optimized for doing reads. OLTP system, OLAP system. Now when you have BW system, which is powered by HANA, which is powered by Means for BW, HANA is the database. For BW, HANA is the database. Now, when you have a single table that contains all your measures, then why should you go for star join? Because we discussed in a star join, when you have these different tables which are normalized tables, on the ECC, all these tables like VBAK, VBAP, VBRK, VBRP, so these are billing related tables. These are billing related tables. So here you have 4 tables now. Now when you want to join all these different tables directly on ECC on HANA, then here you can apply star join. But when you're trying to already denormalize data and put in a single table, why not directly go for an analytic view? Okay, analytic view are very much optimized for mass aggregation of data for parallel processing of a query. When you have all your requirement in a single table, let's say you get whatever the requirement that you have in a single table, simply go for analytic view. If you have all your requirement in a single fact table, go for an analytic view. If you're not having from a single fact table, you have from multiple fact tables, something like this. For multiple fact tables, go for a star join. So these are mainly for operational kind of reporting. These are mainly for historical reporting, history. You get data over here, you transfer data into BW in batch processing. So analytic views are mostly suitable for data warehousing solutions like BW, and star joins are mostly suitable for when you have a suite on HANA, ECC on HANA, CRM, S4 on HANA, S4 on HANA. All these are suitable for star joins. So we have to see one more data model. So we know how to create using a star join. But you see, when I want to combine 2 analytic views, there is an example. If you want to combine 2 analytic views, or an attribute view with an analytic view, or a calculation view with an attribute view, we see there are other views as well, like attribute, analytic, calculation. You have other views. If you want to join, union, projection on any of these nodes with any of the data models, then we have to go for right click on the calculation view, click new, go for the data category cube. So until now we created dimensions, we created cube with star join, but we did not see how to create cube. So this we're going to see in tomorrow's session, how to create data models of type cube. Cube data models are especially used when you want to use any of the operators, any of the views. And whenever you execute cube data models, it executes on a, I deleted that slide, okay. It executes on a C engine. There is no SQL engine. So cube cannot execute on SQL engine. It can only execute on C engine. Okay, let me try to conclude this session. We are seeing the topic calculation views. So calculation views are used to join, union, views or tables. There are three data categories inside a calculation view. One is a dimension, used for master data, start join, when you have multiple fact tables, when you create data models on operational level, cube data model, when you want to use any of the views or tables, any of the operators to execute on a C engine, we go for cube. If you have any questions, please ask me. So tomorrow we are going to see the next topic, which is calculation views of type cube. And once we complete the topic, then again, we will revisit to all the views, how they are processed internally. We'll go one step down to whatever we are seeing now. Whatever we are seeing now, we'll go one step down to visualize what is happening in the underground of these views. We can see using visualization plan. After completing after completing calculation views of type cube, then we go ahead and see visualization plan in tomorrow's session. Thank you. So there is some questions here. There are some questions here. So when will we use rank node? We use rank node when you want to use rank functionality, ranking functionality, when you want to rank data. If we have an SQL engine which is better than, if we have an SQL engine which is better than C engine, then why we don't remove C engine? What would be the primary use of C engine then? As we just discussed, C engine is for complex calculations, SQL engine for better join determination technique. C engine is also used by data models cube. So cubes also use C engine. So primarily C engine is for complex calculations that we do in calculation views of type cubes. Next, whenever I validate and save views I have created, I get a warning, no rules selected. What does this mean? Rules are nothing but there are predefined rules, means validation rules. So system has predefined validation rules that are part of the system. So it is just checking those validation views. For example, whether the join is defined or not, whether you have tables inside a data foundation, whether you have at least one key attribute, whether you have, when you do a text join, did you select SPRES? So all these validation rules it will check. It will check internally, okay, if all these things are there, then it will show a message, validation successful. If any of the rule is missing that system already predefined, it will throw an error, exception, that saying that, okay, this is not there, please verify. So we'll see this, we'll see the different nodes as well. So tomorrow we'll see, until now we have seen only how to use join. We know how to use union. Projection, we haven't seen yet aggregation and rank. Aggregation is in cube, and rank when you want to rank data. We'll see in tomorrow's session. Yeah, I have already informed. Please check. You will already have assignment 2 in your Dropbox. I already informed. Please check. You'll have assignment 2 and assignment 3 in your Dropbox. Please check for the assignments 2 and assignment 3 for this week. So assignment 2 and assignment 3 are uploaded. Please submit back your assignments to email when you complete, just to verify for me. If you're interested, you can submit. Otherwise, it is not necessary. I can just see. If any suggestions, I can give my suggestions. Thank you. There's another question here. There's another question. You don't give tick on a hidden while mentioning the key is not necessary. Yes. We don't hide keys because we're actually hiding the descriptions because we're assigning the descriptions to the key. If you hide the key, then we cannot see key in the report. For example, I have customer ID 001, his name is Raju. If I hide key, I cannot see descriptions. That's why I hide descriptions, assign descriptions to a key, and display the key in the output. So these are the questions we have. So thank you everyone to attend today's session. And tomorrow we will see calculation views of type cube and visualization plan based on information views. Thank you. I'll see you tomorrow. Have a good day to everyone. Good night and good evening. Thank you.